Today we will solve a pretty interesting problem, and I will give you a very interesting solution using some mathematics and not much of coding. And I am pretty sure you will not find this solution anywhere else. It's something unique that you will learn. So here in this problem, you are given a certain number of coins and you have to arrange that in echelon form or in staircase form. That is, in first row, 1 coin, in next row, 2 coin, in third row 3 coins, and so on till you run out of the coins. And in the last row, either it may perfectly match, like in the third row 3 coins and you are out of stock, or you may have some spare coins but you are not able to complete 4 coins here in this fourth row. So you will just return the number of complete stairs that you are making. So in this case 3. So even if it's 6 coins, you can form 3 stairs. Even if it's 7, still 3, 8, still 3, 9, still 3. But if you have 10 coins, then you can form one more stair. So that we have to solve. Now let's see how we can solve it. So let's say we are able to form k coins, k stairs. So we have 1, next row 2, then 3 coins, all the way up to k coins. So these are complete stairs, and in the last we can have any value from 0 to k. In that case I cannot create one extra stair since I needed k plus 1. So this is optional. You can have any value from this to this and still the answer will be same. So let's see how we can solve it. So we know that sum of numbers from 1 to k is k multiplied by k plus 1 divided by 2. So let's say you are given n coins and you don't know what is the correct value of k. So k into k plus 1 by 2, this comes from this part. So this is the coin, let's say nc1. So this part, the complete stairs coin is this. Then we have this extra spare coins which are not contributing anything. So let's add a c here for this. And what is the range of c? This can be from 0 till k. It cannot be k plus 1. In that case, we would form another stair. So this complete is equal to the given input n. So this c you don't know and k you don't know. So let's solve this. So k square plus k, and take the common LCM, that is 2. So it becomes 2c, and send 2 to this side. That is multiply both sides by 2. So it becomes 2n. Everything is clear here. We have just simplifying this expression, multiply by 2 and send this to this side. Then let's make it a square term, that is k square plus 2k plus 1. So this is the square of k plus 1. K plus 1 square is k square plus 1 plus 2k into 1. This comes from a plus b whole square is equal to a square plus 2ab plus b square. So here a is k and b is 1. So here we have added one extra k, so subtract 1k. So this total remains k equal to earlier. So we added 1k and subtracted 1k. That does not change anything. Then we added 1 here, so subtract 1 here. So this term remains same as this term. And then we are left with 2c. And right hand side is 2n. Now next, this term becomes k plus 1 whole square, and this was 2c, not 2cn, and 2c minus k minus 1 equal to 2n. So this is the same equation. We have just taken this whole square. Now let's put the extreme values of c. C can be from 0 to k. So if we put 0 here, this term becomes this term is 0 and this term becomes minus k minus 1. And if we put c equal to k, then this will become 2k minus 1, that is k minus 1. So this term will lie between minus k minus 1 to k minus 1. So let's see this further. So this term becomes either minus k plus 1 all the way up to k minus 1. And it can lie any value between these. So let's look at this term. So here we have, let's say it's k, let's say k is 100, actual k. So this k plus 1 square is 101 square. So what is the minimum? If I subtract this 101, so this k plus 1 is same as here. So if we subtract 101 from this, what will be this? 101 is common and 101 minus 1, which is 100. So this term becomes this. So if we take the square root of this, what will be this value? It cannot be 101, since 101 square, we need 101 multiplied by 101. So it's less than 101, but it's more than 100, because 100 square is 100 times 100, but here we have 101. So it's equal to 100 point something. It will be exactly this value, 100 point some decimal value. So this is this extreme, that is if k is here 100, so it becomes 100 point something. So this term is k point xx, and k is an integer. So this is the lowest value that it can get, this complete term. This is k plus 1 whole square, and from that we subtracted k plus 1. So this term, this is the complete term that I am writing left hand side. The minimum possible value of left hand side is k point xx, and you can see why. Now let's see the maximum value. So maximum is k plus 1 whole square plus k minus 1. So if k is 100 again, then this is 101 square plus 99. Now what will be this value? We had seen the minimum values k dot xx. So clearly the square root of this term will be 101, and we are adding something to it. So it should be more than 101. Now how much more? Can it be 102? So let's see. So let's increase it slightly. So if we had added 101 here, then we would have got 101 times 102. So we take 101 common, and this is 101 plus 1, that is 102. So this is still 101 point something, and this we got from here also. This term was more than 101. We were just looking, is it can it reach 102 or not? So we saw that even if we add a few more values to it, like 2 here, instead of 99 we added 2, still it's 101.xx, and this was already greater than 101. That means this term is also 101.xx. So what is 101 here? K plus 1. So the maximum value can be k plus 1 point xx. So this is the square root of left hand side. So you have to take a square root on right hand side also. Here it's equal exactly. So square root of 2n is either k dot xx or k plus 1 dot xx. So if we take integral value of this root 2n, then it will become either k or 1 more than k. So whatever input is given to us, multiply that by 2 and take its square root and take the integral value. So you will straight away get the number of staircases. This number will be either exact number that we need, or it will be one more. So for that, what we will do, we will see if k times whatever number we got, this can be this k or k plus 1, let's call it x. So this x can be either k or k plus 1. So we will see if x multiplied by x plus 1 by 2 is more than n, then we will return x minus 1, else we will return x, because it can be either exactly equal to k or 1 more than k. Due to this analogy, we have taken the two extremes where the spare coin is 0 or spare coin is k. It will lie anywhere between this range. So this square root of 2n will be either k or k plus 1. So that we will check using this. So let's write the code for this simple formula. So we need to take the square root. So what we will do, k equal to, we have inbuilt square root function in all the three languages, so 2 times n. But here if n is very large, let's say int max by 2 or more than that, then this will overflow the integer range. So better we convert it to long. You can also handle it using taking the square root of n first and then multiplying by square root of 2. But that would be a bit more tedious. So let's keep everything in long. Finally, we will return an int. And then this k is either exactly what we need or it will be one more than what we need. So for that, we will compute the sum from 1 to k multiplied by k plus 1 divided by 2. So if sum is more than n, then return k minus 1, else return k. And let's see if it works. And the solution is accepted, and we are right here. We have done some cheating here, and we did not write, we simplified it using some mathematics and estimation, and we are right here at the top. And here the time complexity should be O of 1. We are computing some fixed function which is independent of n. This is square root calculation, and we are not using too much of space. We are having some variables here which is O of 1. So both the space and time is O of n. Now let's write the same thing in Java and Python. So here also we can store it in long. And we will need to call math.sqrt, and it will return double. So we will cast it, otherwise it will complain. And this is fine. And we need to return int, but k is long. So we will explicitly convert it. We needed int here. And this solution is also accepted. Finally, we will do it in Python 3. And here we can use, it will use int 64, so we don't need to convert it. and this will be some double value. It can be, it should not be double. If this multiplication happens first, then one of them will be even, but we will convert it since it can complain. Although the actual value would be 0.0 only if we see the result. And the Python solution is also accepted. Hope you enjoyed this solution.